Okay. So let's start with today's class. We continue with the process of classification. In the last class, we had discussed about three important classifiers. The first one was a linear discriminant analysis. The second one was support vector machine, SVM. And the third one was a multi-layer perceptron. So we had completed till multi-layer perceptron in the last class. Now, these three type of classifiers are basically falling under machine learning based classifiers. So why am I saying that it falls under machine learning based classifiers? Because to perform this classification task separately, you need to go for feature extraction and, if necessary, feature selection. So this has to be done by the user separately, and you have to provide the either extracted features or selected features as an input to the classifier. So this goes to the input to the classifiers. Okay. So machine learning based classifiers, whenever you're going to utilize that for any kind of real-time classification task, they are very time consuming because you have to extract the features and, if necessary, select the features and feed that to the classifiers. So this is the disadvantage of machine learning based classifiers, that is ML based classifiers. Separately provide features. They can be extracted features or deselected features. That means in real time, whenever you're going to have a data set you are acquiring from a subject via any modality, it can be EEG, FNIRS, anything, you have to perform these two blocks, feature extraction and, if necessary, feature selection. And then you have to go for, finally, classification. So these two blocks are compulsory. I mean, you can omit feature selection, but feature extraction is definitely compulsory, right? And that is why ML classifiers are very time consuming. Whenever you are if you are doing any kind of offline based experiment, then it doesn't matter, right? But in case of real time based experiments, performing two separate blocks is time consuming. It creates a lot of delay in the classification task. So this is the disadvantage. Now, in order to omit the disadvantage of the machine learning based classifiers, a new term which is referred to as deep learning has been introduced. You must have heard this term because there are a lot of articles in different blogs, papers, even in social media. You can find this term deep learning, right? So what is that? So in deep learning, what happens is that the major advantage is, if you're performing classification under deep learning, the classifiers have inbuilt feature extraction and feature selection strategies. So separately, you do not have to go for feature extraction and feature selection and then perform classification if you're doing with real time, if you're dealing with real time experiments. So hence, they are faster during real-time experiments. So if you're going to draw the block diagram, so you have your data set that you have acquired from your subject. Of course, you have to go for any kind of pre-processing. Previously, also pre-processing is there because you have to remove noise. That is something common to all classifiers. And after pre-processing, you can directly move on to classification. And the classifier, whatever classifier you're using, which is deep learning based, it has an inbuilt feature extractor, feature selection, and of course, a final classifier all in one block. Okay. So separately, you do not have to go for feature extraction and selection. So it is quite faster. Of course, the total number of steps are going to be the same thing because feature extraction selection are being done. But in real time, two blocks are omitted from your entire BCI block time. So it is quite faster. Okay. Now, there are numerous number of deep learning based classifiers and hence the name deep learning. So when I'm saying something deep is there, that means you have automatic feature extraction and feature selection strategies within it, and hence the name deep learning. So there is some kind of an extra depth of knowledge within the classifier model itself, so that you do not have to separately provide handcrafted extracted features or selected features. Okay. Now, there are numerous number of deep learning based classifiers, but we are going to study the most popular one, which is referred to as a convolutional neural network, also abbreviated as CNN. So in convolutional neural network, we're going to have the classifier block within the classifier itself. We're going to have three subblocks. So the first block would be a feature extractor that is performed via convolution. The second block is a feature selector that is performed via pooling. I'm explaining all the processes. And the last block is for classification, and that is performed via multi-layered perceptron, which we have studied in the last class. Okay. Now let us see one by one the function of each subblock. So in case of the convolution block, now this CNN can be utilized for images. I mean, it's very popular for images, and it can equally be utilized for brain signals. So your data in a brain signal looks something like this. We have discussed in the previous classes. You have these data points, say k number of data points, and here you have the channels, channel 1, 2 till channel n. So basically you have a k cross n matrix. Even after pre-processing, the matrix structure does not change, right? Okay. So you're going to have certain values in matrix form like this. Suppose I'm considering as an example a 3 cross 3 matrix. Okay, so this is I'm just taking an example of a small 3 cross 3 matrix upon which you have to perform the convolution operation. Now, how am I going to perform the convolution operation? In convolution, first you have to select a small window or it is also referred to as a kernel. Now, usually the kernel is a bit smaller size as compared to the original input. So if my input is 3 cross 3, say for instance, I'm choosing the kernel size as 2 cross 2. And as an example, I'm taking certain values. Now I have to perform convolution upon this 3 cross 3 input using this 2 cross 2 window or kernel. How to do that? First, what you have to do is you have to place this 2 cross 2 kernel at the leftmost end. So you're placing the kernel on the top of this. Okay. Now you have to multiply each of the elements of the kernel and the corresponding elements of your input and then add them up. So what do I mean by this? Basically, you have to perform first multiplication of the individual elements of the kernel and the corresponding elements of your 3 cross 3 matrix. So 2 into 1, right? Then 1 into 5, then 3 into 10, and after that 4 into 20, and simply add these values and just take the average divided by 4, right? Suppose you get the answer, some answer as x1. Okay. Next, what you have to do is you will use the same kernel on the input matrix, just shifting it. So this is going to be your next convolution operation by shifting it. How are you shifting it? The method is to shift from left to right. Once left to right is over, you go from top to bottom. So left to right is over, again you get some value x2, right? Then you go from top to bottom. Again perform the same convolution operation. Then again left to right. Okay, so you continue this process. So ultimately, if you continue this process, the output becomes a 2 cross 2 matrix with some values x1, x2, x3, and x4, which you get after calculation, right? So that means what is happening? Your input matrix is reducing in dimension via the convolution operation. Why is that happening? Because what you are doing, you're extracting the most important features from your input data, right? So that is why I have a larger matrix and I'm shrinking the size of that matrix because I want a summary of the most important information and I want to remove the redundant information. Okay, so feature extraction is done. Next, you have to go for feature selection, and the method via which it is accomplished in a convolutional neural network is called pooling. Now, what happens in pooling? Now, there are two types of pooling which is popularly used in CNNs. The first category is a max pooling, and the second category is average or mean pooling. Okay. Now, in case of any of the pooling operations, be it max pooling or mean pooling, we again choose a kernel size, and that particular kernel size does not have any weights. It is weightless kernel. Okay. So suppose as an example, I'm choosing a 2 cross 2 kernel and it is weightless, right? So suppose I'm performing max pooling right now. So what you're going to do is, you're going to place this on this 2 cross 2 output. Whose output? Output of the convolution operation. And you have to choose the maximum value out of this matrices. Say for instance, if your value was something like this, you place the pooling kernel on this and you choose the maximum value. So maximum value is 6. So your output will be 6. Okay. If you are doing average or mean pooling, then instead of the maximum value, you have to take the average value. So 1 plus 3 plus 5 plus 6. So divided by 4. Whatever is the answer, that is going to be your output. Right? So again, you can see from here, from a 2 cross 2 matrix, we are ultimately getting a scalar value. That means again, we are selecting the most optimal feature. Like if we had done separately feature selection using PCA, right? So the same thing is being done over here via pooling operation. So I'm again learning the most important feature or most important element hidden within my input data acquired from a subject, right? Now, the example I showed you right now is with a very small matrix. Generally, we have a very large matrix K cross N. If you keep on solving this, shifting the matrix, shifting the convolutional kernels and perform pooling operation. So ultimately what you get is, after pooling, you get different scalar values and you just keep storing the scalar values, say 6, 8, 7, and so on and so forth along a column vector. Okay. Now, once you store that in a column vector, you're just going to feed that to your third layer, which is nothing but your classifier, that is your multi-layer perceptron, which we had studied in the last class. So each of these values, this becomes x1, x2, and so on, becomes the input to the multi-layer perceptron that will categorize your desired classes and give you an output. So whichever class it belongs to, the perceptron will have an output 1, and the rest of the perceptrons will have an output 0, that we have studied in the last class. So this is the basic concept of the convolutional neural network. I hope till here there are no doubts. Okay. There's one more thing I want to mention is, in the multi-layer perceptron, we had talked about something which is referred to as an activation function, right? So in MLP, the activation function which has been traditionally used, which we discussed in the last class, it is usually either a sigmoid or a hyperbolic tangent. Okay. Now in CNN, we are performing convolution. After that, we go for the application of an activation function. Then we go for pooling. It can be mean pooling, it can be max pooling. And then we go for the final classification. Now, the activation function utilized in a CNN, it can be any activation function, but the popular one is ReLU, rectified linear unit. Okay. Now, what does the ReLU function look like? Function is something like this: max of x comma 0. That means any negative value becomes 0 over here and the positive values are retained, right? So this is one type of activation function which is popularly utilized in CNNs, that is a ReLU activation function. Nowadays, we have different modifications of ReLU, so I'm not getting into those details. Now, if you have heard about convolutional neural networks or you have performed any kind of project with it, there you must have seen the structure of CNN varies from experiment to experiment. What I mean is, traditional CNN usually has this structure: convolution, pooling, and then classification by MLP, which we discussed right now. Okay. But sometimes if your data set is very large in size, then you might have to perform convolution, pooling, again convolution, and then pooling. And then finally, when it has reduced to a considerable small size, then you are feeding it to the MLP for classification. Okay. But the thing I want to make clear is that you must have seen this kind of structures in different research papers if somebody has studied it already. What I want to mention over here is that this is not the only way of designing a convolutional neural network. Okay. It might happen that optimal results are obtained via this operation, convolution plus pool plus MLP, or convolution plus convolution without any pooling plus MLP. So you can go for different types of combinations. Of course, one thing has to be kept in mind, that the first layer must be a convolution operation, because you have to go for feature extraction to make the classifier learn the most important characteristics of your input data. You may or may not include the feature selection process, and that is why I can omit the pooling layer if needed, depending on the data set, right? And of course, the last layer is going to be your classifier layer. So usually you can use the MLP classifier, but nowadays you can also utilize other classifiers instead of MLP, because ultimately it performs classification, right? You can use over here your LDA, SVM, and so on. Okay, these can also be utilized. But mainly we have three blocks that has to be kept in mind. That is convolution, pooling, it may be there, it may be omitted, and then a classifier. Okay. So is it clear to all of you regarding CNN? Any doubts? Okay. So we are over with the process of classification. We have studied machine learning based classifiers, and today deep learning based classifiers. Now we move on to the second concept, which we had discussed in the first class, that is opposite to classification, and that is clustering. So in classification, what was happening? We had two phases, training and testing phases. In the training phase, the classifier knew the labels of your target classes. It was learning those labels, and in the test phase, we were just testing it and checking whether the algorithm has learned those labels properly or not, right? But in case of clustering, we do not have any specific labels assigned to your specific categories. The algorithm has to, by some means, understand those categories by itself. So there is an algorithm designed for it. The most popular clustering algorithm is the k-means clustering. This is what we are going to discuss today. Now I'm going to illustrate this process of k-means clustering via small mathematics. Suppose you have a data set describing the height and weight of a group of people. Okay. Height and weight. The height is given in inches and the weight is given in pounds. So the data set looks something like this. Okay. Now, what you have to do is you have to randomly select something which is referred to as a cluster centroid. Okay. And that is user defined. But in the question, it is just provided. Okay. So again, you have the same thing, height and weight. So I'm selecting just three centroid values. This has been randomly selected. Okay. Now, for understanding it properly, just mark these values as A, B, C, D. So you're just marking the coordinates because we have to plot all of them. And for this, mark it as 1, 2, and 3. Okay. Now, it is also mentioned in the question that for plotting this, height must lie within a range of 40 to 80 inches. And you're going to have 8 intervals for its plot. And the difference between the intervals is going to be 5 inches. Okay. And for the weight, it has been said it lies between an interval 40 to 240 pounds. 8 intervals, same thing. And the difference between your intervals is going to be 25 pounds. So all this information is given in the question, right? So what am I supposed to do is, cluster centroid means that these are the 3 categories. Okay. I will divide my data close to these 3 categories so that I can separate out them, right? Via some means. So first of all, what I'm going to do is I have to plot this data set and the cluster centroid in the form of a graph. So let us start doing that. So this is going to be your height. And this is going to be your weight. So in the question, it was said that your height will lie between a range of 40 to 80 inches, 8 interval gap, with 8 intervals, and the gap is going to be 5 inches. So we start with 40, 45, 50, 55, 60, 65, 70, 75, and 80. Okay. Now you can just draw some dotted lines. Okay. Now, for the weight, we are going to have a range between 40 to 240 pounds. Again, 8 intervals, and difference between the intervals is 25 pounds. So we start with 65, 90, 115, 140, 165, 190, 215, and draw this horizontal dotted lines. Okay. Now, what we're going to do is we're going to first plot our coordinates, that is A, B, C, D, all these coordinates we're going to plot in this graph. So approximately, let's start doing it. A is 44, 41. So 44, 41. Somewhere here. Next, 59 and 117. 59 and 117. B. Next, 60, 110. 60 and 110. C. Next, 72 and 180. 72 and 180. D. Next, we have 64 and 180. 64 and 180. F is 80 and 182. 80 and 182. So that is F. We will also plot the cluster centroids. So the first one is 45 and 50. 45, 50. Mark it as 1. Next is 80 and 180. 80 and 180. So that is 2. And then we have 45 and 170. 45 and 170. This is our cluster centroids. Now, if you're looking very careful at this diagram, all our data sets are not closer to these clusters, 1, 2, and 3, right? So we have to modify via certain mathematics so that our data sets can be clearly categorized using these clusters. So iteratively, one by one, we're going to check how to modify the coordinates of the clusters. Okay. So now let's move on to the problem. So what is going to be step number 1? Make sure you keep this plot handy right in front of you, right? Because we have to keep on updating this graph. So step number 1. You have to calculate the Euclidean distance between each data point and the respective clusters. Okay. So for simplicity, first write A. So this is one coordinate of your data set. You have to calculate the Euclidean distance between A and Roman 1. So if you remember, A is 44, 41 and Roman 1 is 45, 50. So if you calculate the Euclidean distance, it will be 45 minus 44 whole square plus 50 minus 41 whole square. The value you will obtain is something like this. Similarly, A with respect to 2, you have to calculate. So if you look at the question, I'm sure you have written it down. Same thing, Euclidean distance. For 3, it is going to be again 45 minus 44 whole square plus 117 minus 41 whole square. So for data point 1, A, with respect to all the cluster centroids, you have found out the Euclidean distance. Now what you have to do is you have to mark the Euclidean distance that is minimum. So this one is minimum. Okay. You have to perform the same thing with the other data points. So I'm just giving you the values. So with 1, it is going to be something like this. 2, okay. Again, this is minimum. Mark this. C with respect to 1. This is coming out to be minimum. D with respect to 1. This value is minimum. This is minimum. And the last coordinate left is F. So 2 is minimum. Okay. So you have calculated the Euclidean distance between the data points and the clusters. And you have also marked the minimum distances, right? Now what you have to do is you have to go for step number 2. You have to update the cluster centroids. Now, how will the update take place? Now, for 1, that is the first cluster centroid, we can see that the minimum distance of 1 has data point A. That is, your data point is 44 and 41. For the other scenarios, 1 is not the minimum distance, right? So its centroid coordinate was 44 and 41. So the updated coordinate remains 44 and 41. No amount of modification takes place. For cluster centroid number 2, now 2 is minimum with respect to which coordinates? F is there, this one, then E is there, and then D is there. Rest 2 is not taking place, right? So what will I do is, so 72, 180, I'm going to take those coordinates, 180. So basically the coordinates for D, E, and F, okay? And 80 and 182. You are going to take the mean value of these coordinates. So that means 72 plus 64 plus 80 divided by 3 and 180 plus 180 plus 182 divided by 3. And you get the answer as 72, 181. So this is the updated coordinate of cluster centroid number 2. Similarly, for cluster centroid number 3, 3 has a minimum distance with respect to B and C. So take the mean values of those coordinates. So 59, 117 and 60, 110. If you are considering the mean value, get the output as this. So your new cluster centroids finally becomes 44, 41. Mark it as 1 dash. 72, 181. Mark it as 2 dash. 60, 113. Mark it as 3 dash. Okay. Now you move back to your first diagram. Try to update 1, 2, and 3, right? So 1 and 1 dash is same. There is no difference. So 1 becomes 1 dash. For 2 dash, it is 72 and 181. So 72, 181. Somewhere here, this becomes 2 dash. So initially, 2 was here. It gets updated closer to D, right? And now 3 dash is 60, 130. So 60, 130. So it is somewhere here. So this is 3 dash. So 3 was previously here. Now 3 dash becomes closer to B and C. So visually also you can understand that 1 dash and 2 dash and 3 dash, they are becoming separate categories closer to your 3 different set of data, right? So this is the first iteration. Now in the second iteration, you will continue the same process. So for step number 3, you have to repeat step number 1. So I'm just writing the minimum values corresponding to your data points. Usually A is going to be closer to 1, that is having a value 0. B will be closer to 3, having a value of 4.123. C is closer to 3, having a value 3. D is closer to 2, having value 1. E is closer to 2, having value this. And F is closer to 2, having value 8.06. These are the minimum values. Again, in step number 4, you have to update the cluster centroids. So if you look at this particular calculation, again, the first centroid remains unchanged. The second one has these coordinates. You take the mean of these values and you get this as an answer. And for the third scenario, you take the mean and you get this as an answer. Now look at these final values carefully. They are the same cluster centroids what we obtained over here. That is in iteration number 1 itself, right? So that is why over here we stop. So what is the stopping criteria? Till the cluster centroids converge. Okay, so cluster centroids have converged. They are not changing further. We stop over here. So these are the final centroids. Even diagrammatically also we can see from the graph that the centroids are closer to the respective categories of the data sets, 3 different categories, and they can easily make an algorithm understand, see, these are 3 different categories. Accordingly, you can have 3 different labels. So is the entire process of k-means clustering clear to everyone? Any doubts? Okay, very good. So over here, we have a name called k-means. So I'm going to tell you right now, what does the word k-means mean? So means we are going for mean value calculation, mean or average calculation of the cluster centroids depending on the minimum Euclidean distances, like we have seen, right? And k means that is the number of cluster centroids. So over here we had k equal to 3. You can have less number of cluster centroids or more also. Fine. So this is all about the process of clustering. Now we move on to our final chapter, that is the application of BCI in perception and scientific creativity. So let's move on to that process. Application of BCI in perception scientific creativity. So first, let us have a brief recap on what is perception. Yes, we had discussed in the first class. What do you mean by perception? Perception. So perception is basically a process by which the brain interprets and organizes the sensory information, which we capture via our 5 sensory organs. So what are those 5 sensory organs? Everybody knows that? Response, please. What are the 5 sensory organs of the body? No response. Nobody knows this. No. What are the 5 sensory organs of the human body? Yes. Yeah, and your tongue for taste. Right. So let me write the keywords for perception, which we had discussed. So it is the way brain interprets and organizes the sensory information acquired from the 5 sensory organs. So the sensory organs, you know that we have our eyes, nose, tongue, ears, and our skin. So the perception depending on your sensory organ becomes what? Basically, your sight, your hearing capability, right? Then touch, taste, and smell. So these are your perceptions. So whatever information you are gathering from your 5 sensory organs, they're interpreted in the brain, and the brain gives you an information. Okay, fine, you are actually seeing something. This something is so and so, or you're hearing this noise, or you feel. Okay. So the case study, what we are going to discuss is an application of perception that had been conducted in our AI lab of Jadavpur University, is regarding, so the experimental study is to understand the pain perception of a subject. Okay, so this is what we are going to assess. So for this experiment, what has been done is, our main objective over here is to understand the sensitivity levels of pain from subject to subject, because the same sensation of pain can be extremely painful to one subject, can be moderately painful to some other subject, and can be just a simple form of touch without inducing any pain to some other subject. So this level of interpreting pain perception varies from subject to subject, right? But though it is varying from subject to subject, but we need to understand, like for any specific subject, given any specific stimuli, whether, I mean, how much intensity of that stimuli is painful to that subject. That is important to us, right? Now, the question is, why are we trying to find all these things? I mean, pace perception levels is varying from subject to subject. So what? What is the main application over here? Basically, this information is quite necessary and definitely ignored by a lot of people, because hardly any experiments are conducted on the subject. Why is this information necessary? Because at times, for different types of diseases, one might have to go for sessions like acupressure or acupuncture, right? So if you heard about these sessions like acupressure or acupuncture, in acupressure, different forms of massages is given to some specific points of your muscles, so that whatever disease has been occurring at some particular part of your body, there the blood flow or the blood circulation increases. So some kind of pain or any kind of fluid retention in that particular region of the body is stabilized. So that is kind of cured with the help of acupressure. In acupuncture, the same thing is done, but certain needles, very fine needles, are punctured inside the skin of the human being, right, at specific points. So if somebody is diagnosed with certain disease that has to be cured by taking these sessions, then the therapist who is trying to provide you the acupuncture or acupressure, that therapist is not aware of your pain perceptual ability, right? Because if that person is providing needles into your, puncturing needles into your skin, or giving you some amount of, applying some amount of pressure on some part of the body part, so maybe you have a pain in the arm, right? But the therapist needs to understand that how much amount of pressure will be given so that your pain is cured completely, so that your disorder is cured completely. For one person, the amount of pressure applied is quite large. For another person, the amount of pressure applied might be very small just to cure that particular disorder. So this sensitivity of pain, it varies from subject to subject. This knowledge must be there with all these therapists. Because if a person who is very sensitive to pain, and if a high amount of pressure is applied, instead of curing the disease will increase. So that is going to hamper the health of the subject. So that is why this information is very, very important for before taking such therapies. Okay. Again, in case of lots of surgeries, sometimes doctor says that this person is very aged, so very little amount of anesthesia can only be undertaken by the body because of the age of the person. So over there, if we do not know the sensitivity level of that particular person, suppose the person is aged and the sensitivity level is very high, then obviously a minimum amount of anesthesia and then performing the operation will almost kill the subject, right? But if the subject is not at all sensitive to pain, I mean, very, very little sensitive to pain, then very mild amount of anesthesia can be given and the surgery can be performed, right? So to modulate the doses of anesthesia for different types of surgeries, you also need to know the information of pain sensitivity of that particular subject, right? So that is why knowing the sensitivity levels of sensitivity levels of different subjects corresponding to pain is a very important information. Okay. Now, the experiment that has been performed in our AI lab, we had three types of stimuli. So the first category of stimuli was heat. So, there are some heating pads which are available in different medical stores, right? So all those heating pads, you can modulate the amount of heat being generated. So by those variation of different temperatures of that heating pad, that was applied to the subject at different intensity levels, and accordingly the brain signals were acquired. And we were also asking the subject like whether this was too much heat or was it creating any amount of pain or redness on your skin or not. So all those questionnaires were undertaken, and parallelly the EEG signals were acquired from the scalp of subjects. So this was the first type of stimuli. The second category of stimuli was bristles. So we did not do not worry. We did not use any kind of needles for this experiment. Instead, we just used different types of combs, and the combs were simply pressed on the palm of the subject. Okay. So there are a lot of combs with very sharp bristles. There are a lot of combs with very blunt bristles. So accordingly, we changed the different categories of bristles to understand the subjective sensitivity towards pain. Okay. And the third category of stimuli that was used for this experiment is pinching. So we just used a small paper clip to pinch the arm of the subject, and accordingly, the subjects were informing us that this particular intensity of pinch was painful, this intensity of pinch was not painful, and so on. Okay. But parallelly, for all these types of stimuli, the brain signals were being acquired simultaneously. So you are aware that the EEG device of our AI lab has 21 channels through which we had performed the brain data acquisition. And the time duration of the stimuli was kept as 15 seconds, and the oral response phase was provided as 5 seconds. So within that 5 seconds interval, the subject was informing us that whether this particular stimuli was painful or not painful. Okay. Now, interestingly, of course, we have to go for pre-processing, and you know what are the pre-processing stages. Basically, one form of filtering, and then we had performed independent component analysis to remove the artifacts. So the frequency bands that helped us to identify the most important characteristics for this cognitive task, the frequency bands were generally the theta frequency bands utilized and the alpha frequency bands were utilized. So frequency-based analysis can be performed in this particular region. But apart from that, we had also done event-related potential analysis and found that P1000 signal was very high when the given stimulus was painful, and there was no P1000 signal when the stimulus was non-painful. Okay. So what we can conclude from here is that this P1000 signal can act as a neural or cognitive marker denoting whether a given stimuli is painful or not painful. So since this experiment was performed for the first time in our lab, so we had to take the oral response just to check whether the oral response is matching with the brain response or not, right? But initially, even if you are conducting this experiment without taking the oral response, because now you know if the stimuli is painful, P1000 signal will arrive in the brain, or otherwise it will not, right? So even if you're not taking the oral response, now directly from the brain signals, you can understand whether the stimuli is painful or not painful. And even if you are taking the response of any kind of physically challenged person who is either deaf and dumb, cannot speak or cannot express their whatever they are understanding. So for them also you can perform this experiment, because right now we know that P1000 signal is actually the biomarker or neural marker to indicate whether a given stimuli is painful or not painful. Okay. So this is the summary of the experimental study conducted in our AI lab under perception. Now, the second category of the BCI application, what we're going to learn today, is about scientific creativity. Now, you must have heard about the term creativity. Like, when do we call someone creative? Any person who is creative, that means that person is able to produce any kind of output that is completely novel or original, and nobody else has performed that thing earlier, right? So that is what we call creative. So initially, the term creativity was usually linked with artistic creativity, like somebody is creating a piece of art, like a painting or a sculpture, or maybe composing a new poem or music or performing any kind of dance or theater performance. So, if somebody is able to do new kinds of artistic stuff, so that was linked with creativity. But slowly, this was the traditional notion of creativity. But slowly, what happened with the industrial era, with technological advancement, creativity was also linked with the scientific domain, because all the inventions and innovations in science that has brought about advancement in technology as well as in the society and helped us, all of us, to grow. All of this was a part of scientific creativity, because they were scientists who had created something new in order to make our lives better, right? Be it electricity or any kind of scientific innovation, it has only helped the society to grow further. So creativity is not specifically linked to the artistic domain as humans used to think previously, but it is very much linked to the scientific domain. And it is even prominent in today's era also, because in order to perform all kind of research, you need some amount of creativity in science, right? Otherwise, new things or new answers to unresolved questions cannot be found out, right? So, scientific creativity means to generate something new or novel within any scientific domain, right? Now, again, artistic creativity, like whenever a person is artistically creative, be it any domain of art, so all those experiments have been widely uh, performed, and it has been checked, like when you call a person artistic creativity, what happens to the brain cells. But the question is that when a person is scientifically creative, how can you denote that the person is scientifically creative? By looking at or processing the brain cells, or rather I would say, like, what happens in the brain due to which one person is highly scientifically creative and another is not. So all these mysteries were never resolved till date. So this was basically the concept of scientific creativity was a part of my PhD thesis, and there was hardly any work, prior literature, that has been performed on this, right? Because artistic creativity was a very popular concept, and even today also there are hardly any papers that estimates the neural underpinnings of scientific creativity. Okay, so there are numerous ways that can be conducted in which where you can assess the level of scientific creativity of a person. But I'm going to discuss just two experiments today. The first one, under scientific creativity, experiment one, is to decode scientific creativity from visuospatial reasoning. Okay. Now, what is this visuospatial reasoning? So, spatial reasoning you must have heard. So, first, let me say that why am I selecting this spatial reasoning? Spatial reasoning is very much linked to create something new in the scientific domain. Why am I saying that? Okay. Now, you must have, in the first year, all of you must had architectural drawing, right? Some part of mechanics was there in the first year for all departments, mechanical drawing and all. So over there, you must have seen that you have to draw something and you have to visualize, fine, if I'm going to fold this in this particular way, maybe you're drawing a triangle, right? And you have to imagine that if you're folding this triangle in certain angle, it's a cone. And maybe if somebody's studying architecture, this cone will be utilized in one part of the architectural drawing. So you have to imagine you're drawing something in 2D and you have to imagine its final output in 3D in your mind. So this is something which is referred to as spatial reasoning. It is very much used in architecture. It is also utilized very much in mathematics. Say, for instance, in coordinate geometry. You want to invent, or rather find out, a new theorem in coordinate geometry. So if you're dealing with 3D coordinates, you have to, try to visualize those 3D coordinates in your mind, which vector is pointing towards which direction. And depending on that, you're going to derive some kind of theorems or corollaries, right? So again, in mathematics, this concept of spatial reasoning is very much important, especially in coordinate geometry, to create something new. Even in algebra also, you must have heard about a lot of mathematicians doing huge amount of mental calculations in your mind within a few seconds. Like maybe they are just multiplying 10-digit numbers within a fraction of a second also, right? There was Shakuntala Devi who performed such calculations. She was called the human computer. So in her mind, she was also performing spatial reasoning. Like when which particular number is multiplied with which particular number, how will you keep those numbers arranged in your mind so that the calculation takes place in the fastest possible route. So spatial reasoning is an integral part of creating something new in mathematics and of course in architecture. And since architecture and mathematics are core subjects of science, so it helps us to decode the scientific creative ability of a subject. Okay. Now, over here, we are also referring to a term as visual. Visual means basically visual. So you're seeing something, and according to your sight, you are performing your spatial reasoning in your mind to create some kind of an output. Now, there is a popular spatial reasoning test which is referred to as about. So, in case you are not aware of mental paper folding, I'm giving a very simple example. Suppose you have a transparent sheet of paper, a square paper, okay? It's a transparent sheet. Now, there are three figures drawn on this. Now you have to fold the paper along these dotted lines, and you have to do this mentally. So this figure is shown to you. Okay, you have to perform this entire transformation mentally and finally produce the, or verbally tell the final output. So once you fold this in any direction, you can fold it because it's a transparent sheet. So what is going to be the final output? So it is going to be something like this and a dot in the middle. This is going to be the output, right? So these are standard spatial reasoning tests, and that is what we have utilized in our AI lab to assess the scientific creative ability of a subject. So if somebody is having high score in performing these tests, that means that subject has a higher probability of being scientifically creative. So during this brain signal acquisition, the brain signals, after pre-processing, were converted into brain networks via the Pearson's correlation technique we had studied earlier. And from there, to quantify each and every brain network as creative or non-creative. So there were two classes, creative and non-creative. We had derived two centrality features, which we have already studied. One is your degree centrality. Another one is your betweenness centrality. So from these centrality analysis, that is degree and betweenness centrality, what we inferred is that Brodmann area number 40, Brodmann area number 40 is present in the parietal lobe. Then Brodmann area number 10, this is present in your prefrontal cortex. Okay. So these two lobes are maximally active if somebody is able to successfully perform the mental paper folding task. Apart from this, there are other two lobe activations, that is Brodmann number 22. That is a part of your temporal lobe. So some amount of memory is also utilized, which is obvious. And since it's a visual based task, so Brodmann area number 18 also showed some amount of activation, which is a part of your occipital. But these activations were very minor. The main activation was shown in Brodmann area 40, a part of parietal lobe, and Brodmann area number 10, that is a part of your prefrontal lobe. Now, what is the function of the prefrontal lobe? Basically, to reason out. Reasoning is the main function of the prefrontal lobe. So there is, of course, this is spatial reasoning. So reasoning is involved. And parietal lobe helps me in planning. So you're reasoning out and you're planning like in which direction, how the paper is folded and what is going to be the final output. Everything is being performed mentally. So this is what that was concluded from the experiment number 1. Now the second experiment through which you can understand whether a person is scientifically creative or not. So experiment number 2 is analyzing the scientific creative potential of subjects via analogical reasoning. Okay. So now the question is, what is analogical reasoning? Analogical reasoning is a type of reasoning where you take an example. Suppose there is an example and you just try to understand the similarity between 2 or 3 examples, and from those similarities, you try to create something new. There are very much popular examples of analogical reasoning through which scientific innovations has taken place. For example, the discovery of the structure of the atom, the atomic structure where the electrons are revolving around the nucleus, that was inspired from the structure of the solar system where the planets are revolving around the sun. So this is one form of analogical reasoning. Again, the circulation of blood within the entire human body with the help of the heart. So an analogy was drawn. So this was actually the way heart pumps blood to the different organs of your body. The analogy was inspired from the way a pumping system distributes water in an entire apartment. Okay, so this was done by Dr. William Harvey. So these are very popular analogical reasoning based innovations that has brought forward different scientific breakthroughs in our society, right? So analogical reasoning is another form of reasoning technique through which we can assess the scientific creative potential of a subject. Now, there is a popular analogical reasoning based test that is already present that is referred to as the Raven's progressive matrix test, or abbreviated as the RPM. This test is sometimes even used in testing the IQ of subjects, okay? Now, in case you are not familiar with what this test happens is that there is a set of figures. Say I'm giving you a very simple example. Suppose the figure looks something like this, a large triangle, then a small triangle and a smaller triangle. larger circle, medium circle, small circle. So larger square, medium square, and there's a question mark at the end. Obviously, you know what is going to be the output. It is going to be a smaller square. So there are certain options provided, generally 8 options till 8. And according to the options, you're going to choose which is going to be the correct answer for this question mark. Now, the pattern I have shown you is a very simple one, just to make you understand. Like you are actually analyzing the patterns taking place in the first row, second row, and accordingly, you are analyzing the patterns and drawing a conclusion in the third row, right? The patterns which are utilized in the RPM test are very much tougher patterns, okay? They're not simple ones as this. So in the notes I have made for all of you, you can have a look at the diagram I have provided. It's a very complicated one. So if anybody is able to correctly perform different sets of this RPM test, the person is said to have a high level of analogical reasoning ability, and hence the person is said to be highly scientifically creative. Okay. So again, for this experiment, we had gone through the same pre-processing steps, and we had conducted brain network analysis via the same features, degree and betweenness. And the conclusion what has been drawn is that the same areas, that is Brodmann area number 40 and Brodmann area number 10, are highly activated during this particular cognitive task. So I'm obtaining the same results from 2 different cognitive experiments. So this also helps me to draw the inference that these are the 2 most important Brodmann areas or brain lobes that is responsible for inducing scientific creativity in one person, right? So if a person is not scientifically creative, that person can be artistically creative, that person can be intelligent, that person can be something else, but everybody is not scientifically creative, right? So that means there is less amount of connections. If the person is not scientifically creative, doesn't mean that these 2 lobes are not working. They are working fine, but the connections between these 2 lobes are very sparse, because by birth, they don't have that potential to create something new in science. Another person might have that potential, right? So this is how we can differentiate between healthy subjects, only the levels of scientific creativity. So this is all about today's class. Yes. Yes, that can be made by practice and learning, definitely to some extent. But according to my inference of these experiments, is that, by practice and learning to some extent, you can increase the connections. That is very much true. But in order to create something extremely novel, to create a scientist who has maybe won a Nobel Prize like Einstein, right? For those kind of creations, I think the genetic factor is also responsible for being right at the top of those research levels, or to just gain the Nobel Prize. So if somebody is reaching that level, I think even I have seen in certain papers, just practice wouldn't help. Genetic factors are also responsible. So again, genetic factor is something which you get only from birth. If some mutations are occurring later, that is different. So that is the thing. Okay, any other questions still here? Okay. Okay, fine.